Hi, this is Prakash from 60 Seconds. So today we'll look at a question based on geometry, based on circles in geometry. This is a CAT 2008 actual question, and let's see how we can solve this using a standard approach, and then can I apply a more non-standard sensible approach by using options. So we'll see two different ways of solving this question. But let me first start with the standard approach. So the question goes like this. Two circles, both of radii 1 centimeter, intersect such that the circumference of each one passes through the center of the other. What is the area in square centimeter of the intersecting region? Now I would request you to pause the video now and try to solve the question on your own. Once you have solved it or tried solving it, after that you can resume back to the video and see the solution. Okay, so assuming that you have tried the question, let us proceed with the solution. So the question says that there are two circles of same radii, that is 1 centimeter, and they are passing through the center of each other. So how can the diagram be? So the diagram will be something like this. If I have a circle here, the center is this, I should have another circle of same radius, and the center of the second circle should be like this. So the radius of each circle is 1 centimeter, and this distance obviously will also be 1 centimeter, because if you look at this line, one end of the line is a center of a circle and other end of the line is the circumference of the circle. So the distance should be nothing but 1 centimeter, which is the radius of the circle. Or for this circle, circle number 2, if I say this is circle number 2 and this is circle number 1. So for this circle, circle number 2, this is the center and this is the point on the circumference. So the line joining will be nothing but the radius. So it should also be 1 centimeter. Now the question wants us to find the area of this region. Area of this region. This is what the question wants us to find out. So let me redraw the diagram to see how we can solve this question. Say this is one center, this is another center. Now, if I want to find the area of this region, what I can do is, I should first try to find out the area of this one part alone. If I can find out the area of this one part alone, I can double this. 2 times of it should give me the area of the whole region. So I will first try to find out the area of this region. To find the area of this region, if I can find out the area of this sector, so if you see, say this is the center O, this is point A and this is point B. What I have done is, I have joined the point of intersection of the two circles with the center of first circle. So I get a triangle OAB and I also get a arc AB such that OAB also forms a sector. So something like this is called a sector. It is like a pizza pie. So this is called a sector. So my OAB along the arc is like a sector. So if I can find the area of this sector and the area of triangle OAB, and if I subtract the area of the triangle OAB from the sector, sector OAB minus area of triangle OAB will give me the area which is shaded here, and if I double that, I will get the required area. So my question breaks down to now, finding the area of the triangle and area of the sector OAB. Now let me draw another figure just to make sure that we are clear in the diagram. Now this is the center of one circle, this is the center of another circle. Now let me join this line and let me join the points of intersection of the circles. Let me join the two centers and the point of intersection. So this forms a triangle, and if you see the triangle, each side of this triangle should be 1 centimeter. Why it should be 1 centimeter? Because if you see, we earlier proved that this is 1 centimeter distance of center from the circumference. Same way, this is center, this is a point of the circumference for the first circle, so this should also be 1 centimeter. Same way, this is the center of the second circle, this is a point on the circumference of the second circle, so this should also be 1 centimeter. So it gives me an equilateral triangle. This gives me an equilateral triangle having each side as 1 centimeter, right? So I know this angle should be 60 degree. This angle should be 60 degree. With the same logic, I can draw another triangle and I know this angle should be 60 degree. So I know that this whole angle here should be 120 degree. Why am I bothered about finding this angle? Because this angle will help me find the area of the sector. If I want to find the area of the sector, I need to know the angle projected by the sector at the center, and I know the area of a sector is given by theta by 360 into pi r square. Area of a full circle is pi r square and area of a sector is nothing but theta by 360 into pi r square, where theta is the angle subtended by the sector at the center of the circle. So this is the area of the sector. So I know the angle subtended by the sector in our case is 120 degree, and I know the radius of each circle is 1 centimeter. So let us find the area of the sector. So area of sector is nothing but theta by 360 into pi r square, which is nothing but theta here is nothing but 120. 120 is the angle subtended at the center, divided by 360 into pi into r square. 1 square is nothing but 1, so we can forget it. This is 123 times, so I get pi by 3. So area of the sector is pi by 3. Area of triangle OAB, area of this triangle will be nothing but, so there are various formulas for area of a triangle: half base into height. We also have a formula which is called half AB sin theta. Half AB sin theta, where theta is the angle included between the sides A and B. So here, by substituting the values, half into A can be this side, which is 1, B can be this side, which is 1. So it will be 1 into sine 120. We know sine 120 is nothing but same as sine 60. We know that sine theta is same as sine 180 minus theta. So this should be nothing but sine 60, and sine 60 is nothing but root 3 by 2. Sine 60 is nothing but root 3 by 2. So this 1 into 1 is 1 into sine 60, which is root 3 by 2. So half into root 3 by 2, which gives me root 3 by 4. So the area of only this segment minor segment AB, area of this segment AB is nothing but area of sector minus area of triangle. So area of sector is pi by 3, area of sector is pi by 3 minus area of triangle is root 3 by 4. And I know this is only one part. If I double this, I will get the total required area. That is nothing but 2 pi by 3 minus root 3 by 2, which is nothing but your fifth option. So this is how we can solve this question. Now if you see, this question is, the only part which is slightly difficult is the imagination part, or trying to figure out how exactly I can derive that area. And once you realize that, then the formulas or the concept that you have to use are pretty simple, which is subtracting the area of the triangle from that of sector. So this is one way of doing the question. Now, what if I am not able to realize that I have to subtract the area of this triangle from this sector, and I'm not able to come up with this concept? So what else can I do? So let me try to discuss an alternate approach, which is by using options. Okay. So for using options, let me draw the figure again once more. Okay. And we'll see how easily we can solve this question. So let me draw the figure again. This is the center of the first circle. Now, if I draw a diameter, can I draw a diameter which is tangent to the circle number 2 at this point? Something like this. This is one diameter, right, which is tangential to the circle number 2. Now, I want this area, right, which is clearly a part of circle 1 completely, or we can say a part of circle 2 completely. But let us consider circle 1 for the moment. So I can say this area that we are trying to find out is a complete part of circle 1, right? Circle 1 has a boundary till here. So it is a part of circle 1. Now, if this is the diameter, I can very clearly say that this area will be less than half the area of the circle. It will be less than half the area of the circle, or it will be less than the semicircle. This whole thing will form a semicircle, and clearly the area that you want is a part of that semicircle. So it will be less than a semicircle. So what will be the area of this circle? Area of this circle will be pi r square, which is nothing but pi into 1 square, pi into 1 square, which is nothing but pi. So I know the area of the circle is pi. So area of semicircle will be nothing but pi by 2. So I know that the area that I am trying to find out has to be less than pi by 2. It cannot be equal to pi by 2. It has to be less than pi by 2, or approximately 1.57, because pi is 3.14 divided by 2, it is approximately 1.57. So the required area, the area that I am looking for, should be less than pi by 2 or 1.57. Now let me try to eliminate some options based on this observation. Now if I see this option number 2, this is 2 pi by 3. Even if I approximate pi to be 3, pi's actual value is 3.14. I approximate it to 3. So 3 and 3 will get cancelled. I will get 2 plus something. But I know my value should be less than 1.57. So this cannot be my answer. So 2 cannot be my answer. With the same reasoning, I can eliminate 4, because here I have 2 pi. Instead of that, here I have 4 pi. So this option 4 is even going to be greater than 2. So option 4 also cannot be my answer. Pretty straightforward, right? So till here I think it is fine. Now let us look at option number 3. Option number 3 says 4 pi by 3 minus root 3 by 2. Pi, if I approximate it to 3 and 3 cancels out. So I get 4 minus root 3 by 2. So I get 4 minus root 3 by 2. Now root 3 is 1.732 and denominator is 2. So root 1.732 divided by 2 will be a value less than 1. Even if I take it to be 1, 4 minus 1 will come out to be 3. So this value will come out to be greater than 3. And I want a value which is less than 1.57. So this also cannot be my answer. So now I am left with only two options. Option number 1 and option number 5. Okay. Now let us look at option number 1. Option number 1 says pi by 3 minus root 3 by 4. So pi by 3. So if I take it as 3, it is something like 1. It will be slightly more than 1. Say it is 1. It will be around 1.04. Okay. Slightly more than 1. And root 3 by 4. Root 3 is how much? Around 1.73. So 1.73 divided by 4 will be what? Around 0.43. So this will come out to be around 0.6. Option number 1 comes out to be around 0.6. I am looking for a value which is less than 1.57. 0.6 is less than 1.57, but it is too less. 0.6 seems too less. Okay. And if I look at option number 5, option number 5 tells me 2 pi by 3. So if this pi and 3 gets cancelled, I get 2 minus root 3 by 2. 1.73 divided by 2, which will give me around 0.85. So this will give me 0.85. So this gives me 2 minus 0.85. It gives me 1.15, which is less than 1.57, and it looks like a more likely answer because 0.6 is much less. Yes, you might argue that there is an element of doubt, or still we are not so sure. So that part is correct. But if I have two options, if I have only two options left, and if I am not able to figure out an answer, I would suggest you should try and take a chance, because the probability of getting it right is 50%, which is a decent probability. But if you have three options between which you are confused, then I would not give you the suggestion. Then I would not ask you to take a chance. But if you are left with two choices, I think it's okay to take a chance. Okay. So in between these two, even if I could not find out anything, I would have taken a chance. And if I could have, and I could have applied a more, logical approach by checking the values. So here I am getting 0.6, here I am getting 1.15. 0.6 seems to be too less, so that's why I am rejecting 0.6. This is just by observing that my area should be less than the area of the semicircle. Now, if you want to make sure that you're getting the right answer, you can do a little more analysis and you can get the right answer. Okay, between these two options also, between 1 and 5 also, you can get the right answer just by doing a little more analysis. And I'll tell you how. I know that the required area is less than that of a semicircle, and it is this area that I'm looking for, right? Now, can I draw a similar circle on the left hand side also, like the way I have circle number 2? Can I draw a circle like this? Something like this I will get, right? I know this is not a very nice circle, but just to get you an idea. So I can get another circle identical to circle number 2 on the left hand side as well, right? Now, if you see, if I draw a circle something like this on the top, if each of these parts was 1 by 4, 1/4 of a circle or less than that, then when I draw this third circle, I should not get anything common. If each of this part is less than 1/4 of a circle, then when I draw this third circle, I should not get anything in common. But I get something in common. It means what? The common area is more than 1/4 of a circle. Okay? This common area indicates that the area that I am looking for is more than 1/4 of a circle. So I can use that as a limiting number. So I know my area should be less than pi by 2 and my area should be greater than 1/4 of the circle. 1/4 of the circle will be nothing but pi by 4. Right? Because it will be nothing but 1/4 of pi r square. I know r is 1, so I'll get pi by 4. So the area that I'm looking for should be greater than pi by 4 and should be less than pi by 2. So pi by 4 is what? Around 0.8. It is around 0.8. So the area that I'm looking for should be between 0.8 and 1.57. 0.6 does not lie between 0.8 and 1.57, but 1.15 does lie. So 1.15 has to be my answer, or fifth option has to be my answer. First one cannot be my answer. Okay, I am saying between the first and the fifth, you can still find the answer, but for that you will have to do a little more analysis compared to the kind of analysis we did when we eliminated 2, 3 and 4 by just taking the fact that the required area will be less than that of a semicircle. Okay, I hope the second part is clear. What I am trying to say here is, this is the area that I am trying to find out, and if this area is less than 1/4 of the area or is less than the quadrant of a circle, then when I draw 4 such circles, each will take only a quadrant of a circle, so there should not be anything common. Since the area being captured is more than the area of a quadrant, that is why we are getting some part which is common. So the area that we are looking for should be more than pi by 4 or 1/4 of the circle, which comes out to be pi by 4. I hope this concept is clear. So through this video I have tried to show you that yes, we can always apply the standard approach, and it is not a good idea to always overlook the options. Please always keep an eye on the options as well, always, and see if you can smartly eliminate some options and get to the answer in a different way. Okay, but if you can get the answer using the first approach, the standard approach, nothing wrong with that. Whichever comes to your mind first, please use that. Okay, so there's nothing wrong with the first approach also, and if you do the first approach and if you can get the idea fast, then the first approach also would not take you more than 40-45 seconds. So, but I'm saying, in case you are not able to think of anything in the exam, the second approach makes the question much simpler. So I hope you understood both the approaches. If you still have any questions, please post them below and I will answer them as soon as possible. Thank you.